You're welcome. Let's go ahead and get ourselves started today. We have all sorts of good stuff coming on today, and we're actually sort of shifting our gears a little bit as you finish up some of the assignments in terms of thinking about creating different types of geometry and forms to go through and be able to sort of create objects on a small scale. We're going to actually kind of shift our attention to actually creating objects on a very big scale, but really using the same principles. So we're going to start off today by talking about rendering and visualization just a little bit. We're going to talk about that some more in terms of exterior renderings and controlling the daylighting and how materials kind of play into that, which is something you'll do in terms of illustrating your design concepts and communicating to people that you want to kind of help sell on the design and explain what you have in mind. But we're also going to move into this whole notion of conceptual design. Let me kind of talk about that at a high level, then we'll get into it. Where for a lot of building projects, as we get going, as we start building a project up, we typically start with a program which says there's a certain number of square feet we want to create, there's certain functionalities we want to create, and we have some very big numbers to work with. For a big building, if you have several 100,000 square feet you need to take care of or think about designing, as opposed to looking at it the way we have been looking, where we start from putting a few walls and then building the project up. It's very helpful to come at it from more of a top-down approach of saying, if I've got to put in 200,000 square feet, really, what's the overall shape and form I could create that would even give me 200,000 square feet? What could that look like? How wide could it be? How tall could it be? Just how might I be able to fit that much space on a site? How many floors would it have to be to accommodate all that? And looking at it that way, sort of making some high-level decisions about the overall shape and form, and then as we are happy about some of those decisions, doing some analysis to understand what the impacts of that shape could be, and then tunneling down to the point where we then start making those forms into walls and floors and typical building elements. So it's kind of a different way of approaching it. When you're doing little things like the research center or a house, often you start with the notion of just placing walls in place because you can think about that much space. But if you really think about trying to design a building like the Wong Engineering Center here, or one of the buildings in the SCQ quad, that wasn't done by drawing individual offices one step at a time and figuring out what kind of building that was going to add up to be. It was really much more the overall form of the buildings was decided about how they'd relate in a quad, and then we subdivided that space into the building that we know today. So we're going to be looking at it kind of from the other end and kind of meet back in the middle a little bit in terms of doing high-level conceptual design and how we can, even at the high level, start to understand some things about the energy assumptions and the performance of the building, and then use that to actually generate kind of a much more detailed building, which will really be the thrust of what we're going to do for the next 3 weeks of the class. Is really, you guys are going to be starting with a very high-level program for a relatively large building, and first go through the conceptual design phase and kind of come up with an overall shape and form, but then give it life. Go ahead and put a structure inside of it, put some systems inside of it, and really get down to a much more detailed design, kind of 1 week at a time. So that's where we're going as a class. Okay, in terms of where we left off last time, let's kind of pick up the whole thread of just renderings and how we work with those. And it kind of picks up on this notion of just materials and how we work with materials. So what I'm going to do is actually just switch back over in Revit to that building project. If you don't have that on your machine, you can go and download it from coursework. It's under section 12. It's under the section 12C. But I'm just going to open it up, give you a sense of just really where we left off last time, and kind of take you a little further down the path of rendering. So we've been building up to this a little bit at a time. We've been placing 3D cameras in buildings, typically on the outside, but we also, some people have been placing them on your interior views. We have these views which are shaded views, which are, somewhat cartoony. They don't look very photorealistic yet. We learned that all the shading that's going on here is really determined by the materials properties. So for each of the different walls, for the ground surfaces, all these different surfaces, there's a couple of appearances. There's a graphics appearance as well as what's called a let me get it right. For each of the different materials. And let's go ahead and choose something. Oh, asphalt's not very interesting. Like ceramic tile or something like that. There's something which is called the graphics appearance, which is typically the shading in any sort of surface pattern. Again, these show up in the 3D views that are just shaded. They don't really have any photorealistic appearance to them. There's also appearance properties, where appearance properties are really, those are the photographic appearances. So this is like some piece of ceiling tile, not that dissimilar from these. This has a little more of a recess to it, but that appearance will be mapped across that surface, and then the appropriate lighting will be applied to it. It'll look very good in the end in terms of being able to do a rendering. So for each of the different materials, you always have kind of the graphics appearance and then the rendered appearance, and we need to go through and control those both. So if we go back over to a view like this, okay, this is just sort of an exterior view of some building. Bring that on up. I've seen a whole lot of flashing going on. There we go. Okay, you can see that in the kind of shaded appearance, the concrete has some sort of speckly pattern on it. You can actually see the ceiling tiles through the window. You can kind of see the grass, all these sort of things coming together. If we wanted to start ratcheting this up a little bit, the way we looked at last time is we could just go ahead and turn on the realistic appearance. Realistic appearance takes us one step further in this whole process. Okay. In that the realistic appearance goes through and it takes those very cartoony trees, okay, and actually translates them into real trees and bushes that actually cast shadows. You can start to see now, there's some degree of shadow being cast by the objects. There's also like some degree of materiality that you can see. What's happening is it's doing a pretty good job of actually taking the photograph and wrapping it on that. It's not doing a really good job of bouncing the light off the building at this point. That's like one step further. So we can start by just sort of changing to what's called the realistic appearance, and that gets you one step further in terms of what's going on. We also talked a little about, you can go through and change these graphic display options. So for example, there's the whole notion, do you want to see the edges in this view? And if I turn that off, getting a whole lot of flashing down at the bottom of the screen, which makes me wonder. This is a little more realistic. What it's done is it's actually subtracted out all the black lines around the edges of things. And that tends to be more the way we perceive it. We don't perceive the world with all these heavy black lines outlining everything. So that's a little bit closer to a rendering. Other things you can do, there's all these issues about shadows and turning on shadows. And let's see if I can turn on the ambient shadows, if you can see the effect of that in this building. Ambient shadows is sort of an effect that, it's very good at softening things, because there's kind of the direct shadows which are cast by the sunlight, okay, and those tend to be relatively harsh because the sunlight's so bright. Ambient shadows tend to be a lot softer. I don't think we're actually going to see the effect here. That's actually the shadows that are cast by the ambient light, so all this kind of just general light in the space, and it tends to soften things out. Yeah, even as you look, I'm not sure if your eyes can see it, if you look to the corner of the rooms or something like that, there's kind of the bright color in the middle, but it sort of softly gets just darker back in the corners. It's this very subtle gradation thing, and that's the effect of the ambient shadows. Really, things are very, very rarely like one flat color. Light does an awful lot of interesting things as it bounces around. We're going to find that there's this whole issue of the sun and how we're dealing with the sun, both in our shaded views and our realistic views, but it's also going to come in and affect us when we actually start doing renderings. The whole issue of the position of the sun is very important, because where that sun is located, like on the face of where you are on the face of the earth, and what that means about the latitude and the longitude and what time of day it is, that all affects really how the sun's hitting your building and ultimately how much light's coming in. We have the notion of sunlighting, as well as we'll learn about artificial lights when we're doing interior spaces. We can put in lights, like the lights that are in our ceiling that have real light values, and that light will be used to bounce around. We also have down in here, the issue of the background. Anything from a very plain nothing background, which is the way it is by default in Revit, I don't know what it's doing. It's like it's rebuilding that menu every time. So this is kind of just the nothing appearance in the background. We can go through and put in here like what they consider to be a sky or a gray in a color, going from, say, blue to gray, something like that. We can also go through and put an image in there. So if you actually have an image of some fantastic background, and let me see if I can find one for you. I actually put some up there on the server last time. Again, they're in session 12. But what do I have in here? Rendering images, some nice background images. I got all sorts of sunrises and forest scenes and all sorts of stuff out here. But if you want to put some dramatic, some sunset in the background, you could say okay. And with any luck, after it stops its little dance down there, I really wonder what that dance is all about. Or some sort of background in there. Now, as you're playing this game, it's important that you have kind of appropriately scaled backgrounds that are from the approximate camera position that would look natural. You know, there's nothing guaranteeing that it's going to look natural. You have to use a little bit of artistry yourself in terms of making that all kind of match up. But you can pull those things together and really come up with some incredible effects. And so far, you know, the cool thing is this is all completely live. I haven't done anything yet that's actually true rendering. This is just kind of working with a more realistic appearance. And the nice thing about this kind of view, in terms of not being a rendering, go ahead and close that up, is it's all live. That really makes me wonder what's going on down at the bottom there. We'll figure that out. So if I come through and I say, look, I can move and shift things around. It's just a live model, just every bit as live as the shaded view. So, try it again. Yeah, I saw that the building sort of it rendered out, or at least as it was rebuilding itself, it slowed down and it didn't show us everything. So let's try it again. So you say, as I go moving. That's looking. That seems like it's doing okay there. I don't know. Oh, over there? Oh, yeah. That's just the interior wall. We've been over here? Yeah, that's just the light reflecting off the interior surfaces. So it all starts with this notion of just doing these, but again, this is not actually the strongest sort of view. If you really want to start getting much stronger in terms of understanding the shadow and the form and exactly how this is going to work its way out, there's another type of view, which is called a rendered view, and let's kind of just go through that pretty quickly. I'm going to switch over to the building courtyard instead. So again, kind of a view that just looks like this. When we render things, there's a couple different options. We can go ahead and render things either on our local machine, or we can go through and render them in the cloud. Uses a very sort of similar service. The big difference is if we render them on our local machines, it kind of ties up our local machine while the rendering's going on. Okay, if you want to render it in the cloud, it sends it off, it happens on some Amazon server, and then you get an email message when your rendering's done. And it's actually quicker in the long run to render things in the cloud because those servers have a lot more processing power. They can do things in parallel and just get notified about it, stuff like that. But for quickie stuff, I'll just do it on my own local machine. Yeah. As students, you all have access to like infinite rendering units. So that's kind of cool from the standpoint you can really render as much as you want to out there. And it's not going to be such a big difference for the exterior renderings. What's so special about exterior renderings is that in the scheme of things that are going on, and really what's the difference between a rendering and even this realistic view, it's the whole notion of how the lighting is hitting the building and ultimately how that lighting is resolved across all the different surfaces. In the exterior world, what's so nice is that the sun is such an incredibly bright source of light compared to any light that we can put into the building. It's a pretty easy calculation. That sun is always going to dominate. It's a very bright sort of light. There's not a lot of subtlety to it. So sunlight's really, really quick to go through and take care of. Exterior renderings tend to be easy because the sun's just dominant. They almost always look pretty good. When we get to interior renderings, it gets a lot trickier because with interior renderings, you have that whole thing. Well, I think you even know if you're taking photographs. If you're taking photographs inside a space and there's a bright window in the background, but you're trying to get people in the foreground to look good, often the people in the foreground look dark relative to that bright window in the background. There's a lot of controlling of the light you have to do to make a good interior photograph. And it's all just really about lighting control, what the range of values is from the brightest to the darkest area, and just having good control over that. So they get more complicated. The cloud's actually pretty good at taking care of some of those things for you, but let's kind of take a look at this pretty quickly in terms of just saying, oh, let's do a rendering of this building from the outside and just sort of show you what it looks like in this version. So we can go through, and it all starts with this notion of really what is the quality. There are different quality settings here: draft, low, medium, high, best. And as we move up that ladder, think about every time, probably the next level taking you twice as long to go through and produce the rendering. So draft, very quick but very grainy, kind of good for seeing, did you even get materials about right, and is the sun shining about where you want it to be? Low being better, medium being pretty good. By the time you get to high and best, those are your finished quality. You're going to put it on the board, present it to the client, and call it done. So don't do those right away. You'll just be incurring a lot of time that you don't need to be incurring. Okay, so start relatively low in the scheme of things. I'll just go for draft for right now. You have the issue of really the resolution, how many pixels you want generated. The more pixels you generate, the longer it's going to take. So screen resolution, 72 dots an inch is fine for what we're doing. If I was going to print this out on a board and blow it out to a poster, then I'd want to put more dots per inch. Okay, but keep it simple for now. Scheme, exterior sun only, that sounds good. For what we're doing now, I don't need to care about any interior lights and the light they're going to be throwing, just the exterior sun's okay. Sun setting, though, this is kind of an interesting one. Right now it says in session lighting. I'm going to show you what it's doing. There is the notion of just putting the sun at a point in the sky, someplace with an azimuth and an altitude relative to where we are right now. So this is putting it at 200 azimuth, 10 altitude. Let me go ahead and switch it to something else, like just from the top right. That's 135. So I think that is, if straight ahead of me is 0, 135 degrees over. So 135 is kind of over my right shoulder. Okay, 35 is the altitude up in the sky, so kind of relatively high in the sky. Okay, we can just go ahead and sort of put the sun over our right shoulder. And that's kind of an easy way to do it. Not necessarily very accurate, but it'll always cast shadows from the upper right, and that tends to look pretty good. If you want to be more specific about it, though, you really want to go through and be accurate about your sun. What you'll want to do is not just sort of put the sun in the sky, but go through and actually say, where are you in the world? What time of day is it? What time of year it is? And we can change it that way to be more accurate. So that would be, as opposed to just controlling the lighting, we can say, let's go through and set a specific still time. Manchester, New Hampshire. Now, that's not an okay place, but that's not where we want to be. Let's go ahead. I can make it Stanford. See if we can find it. Okay. Why are we choosing this? This is actually going to help us just figure out where the latitude and the longitude is. Okay, so we'll know a little about where the sun is. It's actually going to help us figure out what a weather file is that was appropriate for Palo Alto, California. And that'll be important for the second part of class when we start talking about energy. So location actually is important. You need that for latitude, longitude, as well as to understand what the local rainfall and weather profiles are, all that stuff. So I'll put it here in Stanford. We have the issue of what time of day it is. So for example, if it is 11:05 at like 10 in the morning, which is actually pretty close to where it is, the sun will have a very specific sort of height in the sky and orientation to where we are, and things like that. So I can say okay, or apply it. And what will happen is the sun will change a little bit back in there. We change it to like 2 p.m. instead. Okay. Relative to where we are, I'm not sure. I think we're probably on the north side of the building. It's looking pretty dark over there right now. Maybe I could switch over to the other side. Let's go to 8 a.m. So we're getting a little more sun on that face. We can look at really what the orientation is in just a second here. But this is going to go through and allow us to go through and just save a spot. Somebody say okay to that. Okay. Sun really will make quite a big difference. You'll find that time of year will make a very big difference. Oh, even location makes a very big difference. If you're from a place which is at all near the equator, the sun has a very, very different quality, and the shadows are very, very different. Here we're actually relatively far north in the scheme of things. I don't know. It makes a very big difference. Yeah, I'll just leave it at that for right now. In fact, well, let me even kind of show you how that works, just so you get a sense of it. Let me close that up. Oh, if I go back to the default 3D view, now this is sort of, I believe, oriented, so Project North is the same as the True North. I think where we're looking at this is actually from the side of the courtyard over here. So I would say it's kind of on the northeastern corner. That's why I'm getting sun in the morning. I'm not getting it late in the afternoon because the sun's already moved over to the other side. But just so you get a sense of how this works, let me zoom on out. And I can say, let's throw some shadows. That's this little widget that's down here in the bottom of my dancing screen. Okay, so you can sort of see the shadows casting right there. And this is for like one specific time of the day. I believe this was 8 in the morning right now, is where I have this turned on right now. You can see the shadows kind of casting towards the kind of upper left back in there. Let me show you how this actually works though in terms of being really able to control this. I can turn on something called the sun path. Which actually brings up this big old heliodon you'll see. Let me zoom on out so you can see it. So this is basically a heliodon. It's showing the position of the sun in the sky. You see it's now at like 5 in the afternoon. I can go through and change this by either dragging the sun or typing a time in there. So for example, if I want it to be 10 a.m., I'll put that in. And with a lot of redrawing, it'll sort of move itself over there. You could also go through and just drag the sun around in the sky if you want to. Although my machine's being slow, I can move it to some specific time. I'm just basically dragging the orb of the sun up to closer to noon or 2 o'clock. Yes. So actually you sort of see, even there, see that thing that almost looks like an infinity symbol? That's the whole notion of how it's moving around through different times of the year. So this is the full range. Down around the bottom of the ring, you'll actually see different dates. So we can also change the date as well as the time of day and just really get very, very precise. So right now, this is like at 1 p.m. Looks like it's in May or March or something like that. Looks like it's May 10th. I'm looking at the little annotation down here by the bottom. If I change that instead to be like 12:10, as we're coming up right now, you'll see the sun stays much lower in the sky, and you're going to see it's actually casts much longer shadows. Okay, so just depending upon what time of year, you get very different sort of shadow behaviors. And we actually use this as we're doing passive solar design to think about really how to orient the building, how to take advantage of the sun when we want it, which is typically in the colder times of the year, how to shade ourselves from the sun in the warmer times of the year when we actually don't want to gather the heat from the sun. So we can play around with that, but it also plays into this whole notion of rendering. So sun and sun control, okay, is something we need to do. So let me go back to the rendering real quickly. So here we are, we got some specific time. Let me bring up that rendering dialog again. So we can control the sun. We can say, what do we want to have happen in the background? Whether I want to put that image or put a sky in there, or just really what I want to do. I'll put a sky in there with some few clouds. Let me go ahead and say, let's just run this and show you what it looks like. I think it's going to complain at me a little bit because some of the materials in this model I don't have on my machine. So the photographic images are missing, but I think it'll do okay. I think they're more on the interior finishes. So what it's going to do is start by going through and computing just a lighting model. So based on the lights, and you can see there's no artificial lights, it's just based on the sun, it's going to say, great, given the sun and the sky and these surfaces, as the light's all bouncing around, as you know, how is it ultimately going to resolve? How much light is going to hit each of those different surfaces? It's just trying to figure out the brightness of the surfaces. Okay, and then based on those brightnesses, it'll take the photographic material and marry those things together. Okay, this is kind of early in the morning, so actually it's not actually all that bad for an early morning rendering, in that the sun does tend to have sort of this very kind of soft, diffuse quality. It isn't very bright at this time. You know, for this rendering, as a draft, okay, different things I should tell you about. As a draft, you'll notice, or low at this point, it's still kind of coarse. It's very relatively pixelated. The patterns aren't incredibly well resolved just yet. As we ratchet things up, it'll get a little bit finer in terms of how it resolves those things. Yeah, the gradation will look a little bit better. The lighting will have a little more bouncing and softness to it, but it takes more time. So you have sort of a choice there, but really where you want to go. But if this looks pretty good, let me tell you a couple different things you can do. One is this. We've rendered this. This is basically a snapshot in time right now. So I can save this. If I want to get back to it later, I'll say save it. And I'll make it building courtyard. This is like low quality. If you've put the work into rendering this, one thing you can do if you're not quite happy with the degree of lighting or the brightness is you can go through and adjust the exposure. And this is very much like taking it into Photoshop or iPhoto or something like that. You know, you've done the work, it's computed something. If you're just not happy about the range of values here, you can say adjust the exposure and just, either brighten it up or darken it a little bit. Let me see if I can sort of brighten it up just a hair. Okay, I'm going to take it up a little. Okay, that's a little bit brighter. So if that's a little more pleasing to your eye, super. You've just made a photographic adjustment to it to kind of change the range of values. I can take it up brighter still. Okay, see it's getting washed out now. Very washed out. And the sun is brighter than you could possibly imagine. So as you're making these sorts of adjustments, use this judiciously. Go ahead and tweak things, okay, but don't go hog wild, because you could get these effects where you're ultimately just whiting everything out. Something like that. So that'll sort of give you something that, actually, that's not too bad. That's a little bit clearer. If we sort of want to sort of say that it's going to be about this bright, you know, we can have something like that and have the exterior rendering.
So in that case, you can't say, well, this is like an accurate morning in December.
Well, here's the funny thing about all those things. Even when you're taking photos with your camera always scales the amount of light from what it perceives to be the brightest to the darkest and sort of adjusts things. So we could actually go through and compute the actual luminance values on all of those surfaces and be 100% analytical and accurate about it. But what is it? All photographs are inherently subjective because they're always scaled on these fuzzy top and bottom of range things. So in a way, you're right, yes, but it's no worse than any photographs because all photographs really have that same problem. They're always just sort of more representational than they are actually, you know, accurate from an engineering standpoint. Okay, so you can go and do things like this. I could ratchet this up. That wasn't too bad for a low. You know, took a couple minutes. That wasn't too bad in the scheme of things. If I went through and I ratcheted it up to medium or high, you'll find it takes a lot longer. You know, it could take 10 minutes. It could take 20 minutes. Now, sun renderings of the outside, they tend to be fairly simple. So in terms of what you have to worry about with the amount of calculations for the lighting. So they tend to go pretty fast. Interior renderings in particular are the ones that get you in trouble. Because interior renderings, if you have, think about how many different sources of light are in this room. And if each of these light sources, ultimately, we have to resolve and bounce the light around and figure out just how much light is being thrown on any one surface from all of the different lights. It's a lot of calculations. So they tend to take a lot longer. So the other alternative you have is you can say that, you know, rather than rendering it here locally on my machine, I'd like to go through and render it in the cloud. And how does that work? Under the View tab, you choose Render in the Cloud, and then it gives you this option of basically choosing which 3D view you want to do, all of them or a single one of them. You know, what you want to have, a still image or a panorama. A panorama, just so you know, is, okay, still image, single camera shot, looking right at one specific spot. Panorama is camera in this spot, but let me go ahead and pivot 360. Okay, so it gives me a camera that I can orbit around and do that too. Okay. Illuminance, that's the one that's going to give you the true values of you know, the illuminance levels on each of the different things, on each of the different surfaces. Standard versus final, I'll just go for final. You know, when it's going to the cloud, there's not much of harm in going ahead and ratcheting up and getting really good settings because it's going to go very, very quickly regardless. Image size, leave it at medium, that's fine. Exposure, you can say use your Revit exposure settings or use advanced. I actually tend to go for advanced because it uses its own algorithms to try and scale the top and bottom of the range and give you a very smart rendering based upon like how much light is there. PNG or JPG. And the important thing is crowd credits available. It says unlimited because you're part of the education community. If you come here and yours does not say unlimited education community, talk to me. We need to get you set up with another education community account because a lot of us created Autodesk IDs before they had this free service in there. So if you're not getting unlimited, okay, we just need to create another account for you because the new one through the education community will be unlimited. Okay, so you should all have access to that. Let me start that. It's gathering some information. It's transmitting it all off to some Amazon server.
Before you have that rendering, then you open where the button in Autodesk to render, like in Revit.
Oh, in where to render in Revit?
Oh, I see. It's right.
There's a couple places. One's render at the top up there. The other is, it looks like a little teapot down here. Okay, now we can wait. Yep. I told it to wait. That's interesting. I want it to actually continue in the background. I think I changed the service around. I should have checked off the thing that said send me an email when you're done, because that would actually be better. Oh, I see. No, it's actually complaining because it's not finding those materials. Okay, now I can continue in the background. Watch out for that. That's actually sort of annoying. Every once in a while, these dialogues pop up in the background behind other dialogues, and you're waiting, but you're actually waiting for like something that's not there. Okay, it's off working. We'll go back and check on it later. It'll ping me when it's actually ready. Okay, that's the story on rendering. We want to just get you going down there because for this next assignment, we're going to have you do some exterior renderings of the designs you propose. Okay, so just kind of file that one away. Okay, but let's actually talk about how we can approach the whole issue of, you know, how did we even get to here? How did that building get to be that form and get subdivided into offices and stuff like that? Really, if I tell you I want 500,000 square feet of building, where do you even start? It's kind of a big problem, and you aren't going to get there one room at a time. So again, we're going to look at more of a top-down process that I'm going to call conceptual design. and see if we can walk you into that. So to do that, what we're going to do is I'm actually going to switch on over to, just a blank project file. We're just starting with a clean slate here. And as we get started with our clean slate, let me see if our guest for the second part is here. He's not here right now. Not sure what's going on. Well, we'll see what's going on. Back over here. As we get started with our clean slate here, there's a couple things, though, we can go ahead and set up just as a framework for working with our building. One is, any sort of building, before we get started, there's probably some notion of like the different floor levels or floor-to-floor heights. And having an understanding of the floor-to-floor heights will help us as we go through and start creating different shapes to think about how that's actually going to get divided up into floors. So just that's a good thing to sort of start with. Another good thing to start with is just this location of where are you on Earth. That's another good one. So let's see if we can kind of take care of those two issues and get ourselves going. Oh, looks like my rendering's complete. Brief aside, we'll go over, take a look. Not too awfully bad. Similar in some ways. It's smoother. Kind of an interesting thing. Notice there's this funny thing. Notice the glass and kind of the reflection of the other half of the building in the glass. So, definitely it sort of does a pretty good job. Again, it's a very sort of crude rendering in the scheme of things, but then again, it was pretty quick. So with this one, we submitted it 2 minutes ago. It took about a minute to do this or something like that. Whereas on our machine, that might have taken 5 or 10 minutes or something like that. So take advantage of the cloud when you can. Okay, let's just hide that away. Go back over here. So we're going to go through and set up a little bit of information about this project. One thing might be, just its location. And under the Manage tab, we can set up the project location. I always have to find these things. I think it's up there. There. In the Manage tab, it looks like a little globe with a pin on it. Let's just choose it. Let's give it a project address. So where would you like to put our building today? Palo Alto's always... It's boring from an energy standpoint because it's kind of a relatively mild climate here. In the scheme of things, we don't have very big problems in Palo Alto. It's much more interesting to put it in, what's that? London's good. I'll go for London. Okay, then what would you prefer? Give me extreme. What's a good extreme? Well, that's actually kind of warm. I used to live in Singapore, so... What's that?
Saginaw, Michigan.
Saginaw. Okay, executive decision. We're going for Saginaw. I've actually been there. Let's see if we can find it. Saginaw. Okay, Saginaw and... So why do you choose that? It just sounded good. Okay, it'll be cold. That's fine. We'll say okay.
I can make up names too and happen to be places.
Next time for you. Okay, so we're in Saginaw. What have we done? We've chosen a latitude and a longitude, and this is actually going to help us understand how high the sun's going to be in the sky at different times of the year. It's also going to help us understand the weather profile. So, and that's very critical as we're thinking about designing our building, because cold weather buildings, warm weather buildings, we have to think about really what problem are we solving? Are we needing to heat the building or cool the building, and just how intense the sun's effect's going to be? The other thing we tend to do is we start off, again, with this notion of just floor levels. It just helps us take a volume and divide it into something that feels like areas. Okay? And to do that, go to any of the elevations. I'm going to go to the south elevation, for example. And you'll see I got a couple floor levels there. Now, 10-foot floor levels is actually pretty small. If you've ever done kind of real building projects, 12, 14, 15, you need some space in there because we need to not only have the space that we perceive between here and the ceiling, but we need space above that so that we have room for the structure, the mechanical equipment, the piping, all that stuff. So I'm going to suggest maybe like 15 feet, not 10 feet. 10 feet is actually pretty low. Maybe in a residential scale that'd be appropriate, but I'm going to shift that to be more like at 15 feet. Now, we want more than just probably 2 floors. Yeah, as I'm thinking about this building, maybe it could be up to 10 stories. I'm not quite sure. So I'm going to add some more floor levels in there that'll let me, be able to handle that sort of a case. And how I do that is under the Architecture tab. There's this tool which lets us create levels. We've played around that a little bit when we talked about, kind of levels for the different houses, the multi-level buildings. I can draw levels by just sort of choosing the drawing mode and pulling left to right. That'll actually sort of work. Or I can pick. And I'm going to pick only because it's sort of a very quick way. Let's see if I get that again. And use the offsetting tool as a way to create things relatively quickly. So here's what I always like about offsetting. I can say, I'm going to pick a line, but I'm going to duplicate something that's a set distance away, like 15 feet. So the nice thing then is I can hover, and every time I'm clicking, notice it's creating a new floor level for me. So over in the floor plans, we're getting a new floor level. And it's creating new levels. So that's just kind of a quickie way. Again, you don't have to be offsetting and doing it that way. You can be drawing them. That's okay. Just whatever works for you. I just tend to like offsetting because it's a really quick way of generating a bunch of them. Okay. So I'm just going to give myself some levels. Again, I may not use all these levels. I'm just giving myself some room so that as I create some different shapes, I'm going to allow that it could possibly be 10 stories. There are probably some site restrictions, some planning restrictions, which are going to bound you and tell you that it only can be a certain height, and that's ultimately going to dominate. Is it 50 feet? Only 5 stories? Well, that's not very high at all anymore, is it? How did they build those bigger buildings downtown?
They get rezoning stuff.
Special allowances? Okay, that's tricky. Planning.
Some are under 5 stories, they seem bigger.
It's amazing how much more complicated this has become. Okay, so all we have so far is a framework. We don't have anything that even looks vaguely like a building yet. Okay, let's talk about how we can actually go through and create a building. So let's just kind of make up a building. That'll help as we get started. We need some sort of program. I need some sort of marker. So, let's say we're going to have some building, let's say the total area is going to be somewhere around, let's say 400,000 square feet. Okay, and within that, we'll make it fairly easy right now. Let's say maybe it's going to be some retail space with some office space above it, something like that, like a lot of these downtown buildings in Palo Alto are. So we'll say that retail, let's say 100,000. We'll say office is going to be 300,000, just roughly. Again, I'm just sort of making these numbers up, but it gives us something to operate on. So let's think about how we can start creating a building that has that kind of a general form to it. So it all starts with the notion of kind of sketching out a mass, sketching out just a form that might be able to contain that much space, and just stretching and pulling and shaping it and see if we can actually come up with that number of square footage, or that amount of square footage. So to do that, I can do it a number of different ways. I can do it down on the floor plan in level 1. Maybe that's a good place to do. Maybe as a starting point, let me do this. Let me just start on level 1, and I'll just make a sort of relatively simple rectangular shape, and we'll kind of get fancier from there. When I want to create this thing, which is really just a form, what they call it in Revit is a conceptual mass, but a form that lets us go through and experiment with the space, we look under the Massing and Site tab, and we find something there called In-Place Mass. And in-place mass, we actually talked a little about in this class when we were talking about in-place elements and kind of extruding them and blending them and stuff like that. And it works very much the same. I can say in-place mass. It's going to say, by default, masses aren't visible, so I'm going to make them visible for you just because you're asking to edit one. I want to make sure you can see it. I'll say sure, that's fine. Give it a name. Call it building form. Okay, We are ready. We are ready to start drawing. So, how do we draw? We can start by just grabbing, I'll just put a big rectangle down here. And again, I'm not going to worry too much about its size just yet. I'll get some feedback on that in just a minute. I'm going to actually rotate that around into 3D, just so we can see it that way. So there it is lying on the floor. And I can choose that rectangle, and I'll say create a form with it. A solid form, so solid or negative. Okay. And it makes a basic box out of it. Okay, so now I got this big old box. And this big old rectangular box, it's not very interesting yet. It's going to get more interesting in just a little bit here, but it's a start. Okay. We can do a lot of things to this box. We can just sort of stretch and pull on its edges and kind of give it slightly different shapes. We can put parameters on this and kind of stretch it programmatically. We can kind of give it specific values we want it to be. But as a starting point, let me just kind of let it be a big old box for just a second, and then we'll make it more interesting. I'm going to finish the mass. Okay. Finishing the mass says, I've edited that basic form. I can go back and add more to it and change it in just a bit. But now it's basically a big old box, and I can sort of stretch and pull on it. You might see that my big old box actually does have some sort of volume. I do know that it is, 618,000, almost 619,000 cubic feet, and there's a gross surface area to it, but there isn't a floor area to it right now. And the reason is we haven't actually divided it up into floors just yet. It's just a big old volume at this point. So the next step is to actually go ahead and take this and divide it up into the floors. So how do we do that? With that big old box selected, you get this choice over here called mass floors. What do mass floors do? They take your big old mass, they take those floor levels, and they intersect those two things together. So if we say mass floors, and I can choose all those different levels. I may not need them just yet, but I'm going to choose them all anyway. Say OK. Okay, we can divide this thing up. Let me shade that for you. And again, let me show you what I did. I just chose the mass, whatever the shape of the mass was, and I said mass floors, and chose the floor levels I wanted to divide it by. Now, let me take one out just so you sort of get a sense. If I don't really want level 3 in there, I can take that one out.
Is it solid though, or?
Now, at this point, it's kind of like this big transparent void, and all we really do is we have these mass floors. They're not even real floors yet. They're just like planes that are going to let us calculate some area. It's going to become solid. It's just not there yet. Okay, so I got these mass floors. I'll put 3 back in there. You can choose any of those floors. For example, this is floor 2 at level 2. You can see that it actually has a floor area of around 7,000 square feet. Okay, a little bit higher than that. The nice thing is, if I roll on out and I grab the mass and pull on it, okay, it'll update that. All of a sudden, it'll show me that the exterior, or the floor area, this one's now 10,000 feet. If you choose the mass, you'll actually see, it'll report that the total of all the floor areas that are in here so far are currently around 62,000 square feet. So, I got a ways to go till I get up to 400,000. Well, I could go taller. That's up to 103. I might need to go wider. Now I'm up to 323. Maybe it'll be kind of skinny-ish over there and long over in this direction. But can you see I'm just sort of playing around with it? I'm just trying to come up with some form that I think looks good, and I'm really quickly getting some feedback about what the impact of that's going to be. And that's really what we want to be demonstrating right here. Let me do this. I'm going to go through and create something else to help us. These mass floors that are hanging around over here, they're pretty good in terms of, just being able to kind of report some values. But it'd be really nice to actually have a little bit of a schedule hanging around so I can sort of see what the total is and kind of look at those two things side by side. So how you can do that is just by creating a schedule. I don't think there's one set up by default. Let me see if there is. Nope, not by default. So I'll say view. Going to create a brand new schedule. And I got all these things I can schedule. I'm going to go down to the mass categories, and you actually find that mass floors is one of the categories. And I can say, okay, let me put the level in there. Let me put the floor area in there. I'm also going to put the use in there. So I'm going to start caring about really which ones of them are office and which ones are retail in just a little while here. I got those. Let me go back to that 3D view and see if I can actually tile these into place. Not too bad. Let me close that one up. I don't need him anymore. Is it done? It's done. Okay, tile that up. So here's the deal. I got this nice floor, this building shape over here. I can stretch it on out. See, it changes those things. Yeah, it'd be really cool if I actually had like a total on this thing so I could actually see where I am up against 400,000 square feet. How I do that is I go over to the schedule, and I can say, I'd really like a grand total line. I always have to tell it what it is I'm totaling. So I got 556,000 square feet, not too bad. $497. Now, I can also start thinking about the different floors having different usages. So there's this whole notion of retail versus office. I could say, I want level 1 to sort of be a retail floor. I'd like level 2 to be a retail floor. It's funny, why is level 3 at the bottom? Office, I can make these other one office floors. Not so bad. If I'd like to subtotal those a little bit so I see how much office and how much retail I have, I can just introduce a little bit of a sorting by the usage and put a subtotal on that so we'll see the office versus the retail. So about 600,000 square feet of office right now, about 139, totaling up to close to 700. So I can, just keep on pushing and pulling. Okay, we're not doing too awfully bad. Now, I know in the back of your mind you're saying, okay, this is kind of okay, but this is a pretty boring building. Yes?
How do you change it? If you want it to be just a regular square, how do you change it?
A very good question. A very good question. So let me kind of show you something, then we'll take our break and we'll keep on playing with that. You say you want to change, not this regular square. You want to have something that's much more interesting. You can, and here's how you do it. You're actually going to go back and edit the form. Okay, and then the floors will sort of fill into the form. So think of that envelope or that form as being a big old envelope that just floors spill into. And if you take that and you say edit in place, something that you're probably far too familiar with at this point from other things you've been doing, we say edit in place. We get that basic thing. Okay, so I can go through and kind of keep on pushing and pulling the sides. That was kind of okay. What if I did something a little more interesting, like I actually pulled an edge? Kind of torque that out. Okay. Pull that even further. Kind of like a self-shading building. Let me zoom that out. Okay, looks pretty strange. We say finish the mass. Okay, notice it adapts all the floors to fit within that. So we can do things like that. We can sort of twist and pull. We can just either pull the edges, pull the vertices, things like that. Other things you can do that are kind of cool are, for example, let me edit that form. Why not a curve? Oh, let me do a couple of different things. Oh, well, for example, I'll draw like, oh, it looks like I'm still on the side there. Hang on, let me see if I can do this. I'm going to draw this. Let me say placement plane. Let me pick a plane. I'm going to just actually place a plane right on the side of that building so that I can draw something that looks like that. This little guy, I want to say, make him a form. So I have more like the little L-shaped thing kind of hanging around in there. So again, adding up in there to kind of just now I have like the little L that's attached to the building. But really, any shape is kind of possible. So for example, oh, these were already created as forms. Let me see the best way to do that. Hang on. I can go through and edit in place. I'm just going to put it down on the floor for now. Actually, no, I'm drawing in the wall right. I'm drawing up right now. Drawing in 3D is always a little bit strange. We put it down on level 1. That one we actually had a choice because as a single profile, it could have been a circle, it could have been a cylinder, it could have been either one of those. Looking pretty good. That's still kind of two separate pieces like now. Let me see if I can sort of join those. Actually, no, I think it'll work. Okay. So we can start creating all these different shapes, still get the values put out in here. Yeah, now if I decide that no, I really want that to be the tall tower on the end. Although, looks like I only have 10 stories to work with. So Palo Alto's limiting me there. Push and pull that shape. Okay, but we can play around with the overall form and really see how we're doing and just do all sorts of things. You know, sometimes it's stuff like this and you're thinking that's really kind of easy or very kind of relatively straightforward. Let me go through and create another mass for you because again, you don't have to make it all in a single mass. You can make several different masses. The other thing we showed last time was, let's make it mass 2. Yeah, if you want to start creating just any sort of arbitrary shapes you can. For example, on level 1, I'll draw this ellipse that's doing that. Okay, up on level 4, I'll draw an ellipse that's doing this. And then up on level 10, I'll draw an ellipse which is doing that. So you can go through and take all 3 of those and loft them together to kind of create very interesting groovy shapes. That's a different form. I also have to divide it into floors if I want it to count. I just get them all. Okay, now we have the floor areas of those. That's a little strange.
It's hard to talk in the view, but are they horizontal floors or?
They're actually horizontal. Yeah, they are horizontal. They're just so distended out there because of the way I drove that. I should go ahead and move my profiles back in. Okay, let's go ahead and do this. Let's break for right now. Please come back in 5 minutes or so, and we're going to continue with this. You got this whole notion of basically being able to create these different things, figuring out uses, and tallying things up. We're going to go one step further, though, and say, okay, great. We got forms. Can we figure out really what the energy impact of these forms might be?